A very good morning to my lecturer, Dr. Sheikh Muhammad Noor. My name is Witeng Chow. My matrix number is 201301607. My program name is Electronic Network Design. Today I'll be presenting about CAA2. So let's begin. This is the list of contents. We have the introduction, which will be covering about the main components used in this experiment, results and observations, which will be covering about calculations and measurements, and also our conclusion. For our main components, we have two main components, that is the capacitor and inductor. And what is a capacitor? A capacitor is basically made up of two plates, one positive plate and one negative plate with a dielectric in the middle. What it does is it stores charges that can be released at a later time. So its main function is filtering, that is, it smoothens out the ripples in a rectifying bridge. As for an inductor is made up of several coils, somewhat like a solenoid, and this shape allows it to store electrical energy in the form of magnetic field. And its main function is to tune circuit to your desirable frequency. Okay, here we have the calculations, and if you take a look at figure 1, under DC conditions, an inductor will behave like a wire when it has its magnetic field fully charged, and a capacitor will be like an open circuit. So having said that, VC, which is the voltage across capacitor, will be equivalent to VR, the voltage across resistor 2. Therefore, we can just apply voltage divider rule to calculate VC. And given my matrix number, the resistance for R2 is 3 ohm, and therefore I'll get VC is 9 volts. Whereas for IL, it is equals to IT. And if you take notice for this circuit, the capacitor is already an open circuit, so therefore this whole circuit will actually behave like a series circuit. Therefore, there's only one current running in this whole circuit, and we can just apply Ohm's law, which is Vt equals to It times Rt, and therefore we'll get It is equals to 3 ampere. Therefore, IL will also be equal to 3 ampere. And whereas for the energy stored in the capacitor, we can just apply the formula half CV square, that is the voltage across capacitor square. After substituting the values into the formula, we'll get that the energy stored in the capacitor is 243 joules. Whereas for the energy stored in the inductor, we apply the formula half Li square, which is the current flowing across the inductor square. And after substituting all the values in the formula, we'll get that the energy stored in the inductor is 31.5 joules. And here is the measurements that I take. So let's have a look at the measurements. So you'll notice when I start the simulation, the current and the voltage slowly rises. This is because the inductor is slowly building up its magnetic field with the current flowing through it. So therefore, the current and the voltage will actually stop at a certain value when the magnetic field across the inductor is at its maximum, which now, if you take notice, it has stopped at the value of 3 ampere and 9 volts. So I stop the simulation, and there you have it. So our conclusion is that our measurement taken from Tinkercad simulation is equal to our calculated value. So this concludes that the simulation is a success and that the circuit constructed in Tinkercad is correct. That is all. Thank you.